Assalamu alaikum warahmatullahi wabarakatuh. Class 8, we are doing chapter number 7, sound. Today we are going to see what are the characteristics of sound. So there are three important characteristics of sound. They are loudness, pitch and quality or timbre. Now what is loudness? It is the characteristic of sound by which a loud sound can be distinguished from a faint sound even when both the sounds have the same frequency. Frequency is the same, but we can distinguish a loud sound from a faint sound by which characteristic of sound? By loudness. So loudness is the characteristic of sound by which a loud sound can be distinguished from a faint sound even when both the sounds have the same frequency. Suppose when we shout, what type of sound is heard or produced? A loud sound is produced when we shout. And when we whisper, a soft sound is produced. So loudness of a sound depends on the amplitude of vibration of a vibrating object. So what are the factors on which loudness depends? Loudness depends on the amplitude of vibration of a vibrating object. The larger the amplitude, the louder is the sound produced, and the smaller the amplitude, the softer is the sound produced. So what is loudness? It is the characteristic by which we can distinguish a loud sound and a faint sound, and both have the same frequency. Now what is amplitude? This is the mean position, this is the amplitude, and this is the amplitude. So larger the amplitude, louder is the sound produced. So this is a soft sound and this is a loud sound. Here the amplitude, this is the amplitude. Displacement from the mean position, this is the mean position and this is the displacement. So here amplitude is smaller and here amplitude is larger. So this is soft sound and this is loud sound. So loudness of sound depends on the amplitude. The larger the amplitude, the louder is the sound produced, and smaller the amplitude, softer is the sound produced. When we strike a drum softly, its skin vibrates with a smaller amplitude. As a result, a soft sound is produced. So smaller amplitude, soft is the sound. And if we strike the same drum harder, its skin vibrates with a large amplitude, due to which a loud sound is produced. So large amplitude, loud sound. When we strike a tuning fork gently on a rubber pad, a feeble or soft sound is heard. However, if we strike it harder, a loud sound is heard. Now this is a tuning fork, and let's see how does its vibrations disturb the air particles. Now as we know that sound is produced by vibrating bodies, let's take this example of tuning fork. I have shown you just now, this is a tuning fork, and when this tuning fork is made to vibrate, what happens? It creates a disturbance in the particles of the medium, that is air, and the particles are disturbed from the mean positions. So these particles now they exert force on their neighboring particles and they set them also into motion, and this process continues. Means this process of disturbance continues in the air till the sound of vibrating tuning fork reaches our ear. So all of the air particles in between the tuning fork and our ear are disturbed, and waves are created in this way. Sound waves are created due to this disturbance, and the sound travels from tuning fork to our ear. Thus the particles in the air, they do not travel to reach the ears. The particles of air do not travel, but it is the disturbance created in the particles by the source of sound, that is by the tuning fork, that reaches our ear. And what is the medium? Sound requires a medium, and here the medium is air. So sound propagates means sound travels due to the vibration of the particles of the medium. As we know, when any object vibrates, it creates a disturbance in the medium, as sound needs a medium to travel. So the disturbance is created in the particles of the medium. They are disturbed from the mean positions, and the particles transfer this disturbance to their neighboring particles. Then these particles again disturb their neighboring particles, and so on. And in this way, all of the air particles in between the source and the ears, they are disturbed, and thus sound is propagated from the source of sound to the ears. So when the prong of a vibrating tuning fork moves towards right, it pushes and compresses the air in front of it, creating a region of high density and high pressure. This region is called compression. In this region, air particles come closer as compared to normal air. This compression moves towards right, that is away from the vibrating tuning fork. And when the prong, now what is the prong? This is the prong of the tuning fork. When the prong of the tuning fork moves towards the left, the air in front of it expands, creating a region of low density and low pressure. This region is called rarefaction. And in this region, air particles get further apart as compared to normal air. When the prong moves towards left and right, back and forth rapidly, a series of compressions and rarefactions are produced in the air. Thus, sound travels in the form of compressions and rarefactions in the given medium. So, one compression and one rarefaction together constitute one wave. So, this is a tuning fork, and these are the prongs of the tuning fork. So, when it is made to vibrate, what happens? The prong moves back and forth, or right and left rapidly. So, when it moves towards right, it pushes and compresses the air in front of it. Now, this region is of high density and high pressure, so this region is called compression. Now, in this region, the air particles come closer as compared to the normal air, and this compression moves towards the right, that is away from the tuning fork. Now, when it moves towards left, what happens? The air in front of it expands, and now it creates a low density and low pressure area, which is called rarefaction. Now, in this region, the air particles, they get further apart as compared to the normal air. So, when the prong moves towards right and left rapidly, what happens? A series of compressions and rarefactions are produced in the air. Compression, rarefaction, and this process continues in the air till the sound of the vibrating tuning fork reaches our ears. Now, one compression and one rarefaction together constitute one wave. Now, factors affecting the loudness of sound. The loudness of sound depends on the following factors. Number one is amplitude of the wave. Now, you know that what is amplitude? It is the displacement from the mean position. So, when an object vibrates with a larger amplitude, it transfers a greater amount of energy. Hence, the energy received by ears is more. Thus, the sound heard is louder. Larger the amplitude, louder is the sound, because a greater amount of energy is transferred. So, loudness is directly proportional to the square of the amplitude of the wave. It means when amplitude of the wave is doubled, the loudness becomes 4 times, and when the amplitude of the wave is half, the loudness becomes 1/4. So, loudness is directly proportional to square of the amplitude. Now, here's an activity. Take a drum, place some small beads on the drum, beat the drum gently with a drumstick. A feeble or soft sound is heard, and the beads move up and down slowly, showing small amplitude of vibrations. Now, beat the drum harder. A loud sound is heard, and the beads move up and down faster, showing large amplitude of vibrations. Thus, loudness of sound depends on the amplitude of the vibrations of the particles of the wave. Now the second factor is the distance between the listener and source of sound. Now loudness depends inversely on the distance between the listener and the source of sound. Now what does inversely proportional means? It means that if the distance between the listener and the source of sound is less, then the sound heard by the listener is louder. Let us take the example of the train. As the train moves away from a man standing on a platform, the loudness of the sound of the train gradually decreases and after some time it becomes inaudible. So loudness is proportional to 1 upon distance, that is loudness is inversely proportional to distance. If distance increases, then loudness decreases. If distance decreases, then loudness increases. So third is surface area of the vibrating object. Loudness depends directly on the surface area of the vibrating object. Larger the surface area of vibrating object, louder is the sound produced. And example is a large drum produces a louder sound than a small drum if we struck them with the same force. Now fourth factor is sensitivity of ears of the listener. Loudness depends on the sensitivity of ears of the listener. For different frequencies, sensitivity of ears is different. A given sound may appear loud to one listener but not so loud to the other listener. So it depends on the individuals also, that is the sensitivity of the ears of the listener. Now unit of loudness. The loudness of sound is measured in decibel. The bigger unit of level of loudness is bell. 1 bell equals to 10 decibel. The unit of loudness, that is bell, is named in honor of Alexander Graham Bell, the inventor of telephone. So when the frequency is 1 kilohertz, the minimum loudness of sound audible to us is 0 decibel. The sound between 50 decibel to 60 decibel is considered normal. Now what is the normal sound? 50 decibel to 60 decibel. And the sound of 80 decibel can be tolerated, while sound above 90 decibel is painful and can have harmful effects. So normal range is 50 decibel to 60 decibel and sound of 80 decibel is tolerable, while sound above 90 decibel is painful and it has harmful effects. Now this is a table for sound and the loudness. Rustling sound is 10 decibel, it is very faint. Then soft whisper, 20 decibel, it is faint. Then normal conversation, 40 to 60 decibel, that is moderate. Loud music is 90 decibel, it is very loud. Heavy traffic, 90 decibel, very loud. Pneumatic drill, 100 decibel, it is very loud. And aircraft engine, 140 decibel, it is painfully loud. Rocket at takeoff, 180 decibel, dangerously loud.